for the next problem, we will have two capacitors. One has capacitance C1 and it was connected to a battery with voltage V, which means that it was charged to it was charged with charge Q1, which is C1 times V. And I have another capacitor, capacitance C2, and this capacitor was brought to the same battery V. This one has capacitance C2, so it was charged with charge Q2, which is C2V. So each of these two capacitors were brought to these circuits and charged with charge Q1 and Q2. Now I take these two capacitors and I bring them into the circuit, and I connect two of them this way. I bring positively charged plate for capacitor C1, and this is charge Q1, plus Q1 and minus Q1, and here I will have minus Q2 and plus Q2, and they are connected by the ideal wire. So what will happen? So let's suppose that Q1 is greater than Q2. Then fraction of Q1 will fly towards this plate, and eventually the charge will be redistributed the way that we still have plus minus, and we again have plus minus here, but the charges will be different. So this charge, let's call it Q1 tilde, and this will be then minus Q1 tilde, and this charge will be plus Q2 tilde and minus Q2 tilde. So what we want to find? We want to find the new charges on these capacitors after redistribution. So we want to know what are, find Q1 tilde and Q2 tilde, new charges on these capacitors. Why do I want to solve this problem? We know well how to find the equivalent capacitance when we bring the capacitors together in series and in parallel when the capacitors were originally uncharged. But these two were originally charged. They were already charged with some charge before we brought them into this circuit. So how to find the new charges Q1 tilde and Q2 tilde? We have to use the conservation of charge. So I consider a box, and this imaginary box will go between, one side of this box will be between the plates of the capacitor, and then this pink is imaginary box. If charge is conserved, and it has to conserve if we don't have discharge here, if capacitance are not ruined, we will have Q1 minus Q2. This is the original charge on the upper plates of these capacitors, Q1 minus Q2, and it has to be equal to the charge that is in the box after the redistribution. This is conservation of charge. Whatever we had within the box, we have to have the same. So what is the total charge within the box after redistribution? It is Q1 tilde plus Q2 tilde that we are looking for. This is one equation, and it has two unknown variables, so we need the second equation. And the second equation, what we will use, we understand that those are ideal wires, so these 2 points are basically the same. So difference voltage across this capacitor will be the same as voltage across this capacitor. These voltages will be the same, which means that Q1. So I remind you that the definition of the capacitance is Q over delta V. So voltage delta V is Q over C. So Q1 over C1, Q1 tilde over C1, this is voltage change across this capacitor, is equal to the voltage change across this capacitor, which is Q2 tilde over C2. Now we have system of two equations and two unknown variables, Q1 tilde and Q2 tilde. So we can solve this system of equations. How we will solve it? For example, I will express Q1 tilde from the second equation, and I will bring it in my first equation. What is Q1 tilde? From the second equation, it is C1 over C2 Q2 tilde. And then I plug it in my first equation. So I have Q1 minus Q2, both are given, Q1 and Q2. And this is equal to Q1 tilde, which is C1 divided by C2 Q2 tilde. And then plus Q2 tilde. So what is Q2? I factor out Q2. Here then I have C1 over C2 plus 1. So what is Q2? It is Q2 tilde, sorry. Q2 tilde is Q1 minus Q2 divided by C1 over C2 plus 1. Now I'm ready to find Q1 tilde, which will be equal to Q1 tilde. Which equation will be used to find Q1 tilde? Let's just use the second one. It is C1 over C2, C1 over C2, times Q2 tilde, which is Q1 minus Q2, divided by C1 over C2, plus 1. C1 over, let me write it a little bit better. Here I have C1 over C2 plus 1. So we found both charges Q1 and Q2 tilde after the charge redistribution, when the capacitors were originally charged. We know Q1, it is C1V. We know Q2, C2V, and our final charges are expressed in terms of what is given. Capacitance C1, capacitance C2, charge Q1, and charge Q2. Problem solved.